just a little bit of background on Arthur and myself. We come from a deep financial services background. Several of us have previously led large AI centers at major US banks, and it's an area that's very near and dear to our hearts. In fact, when we set out to start Arthur, we did so with the intention of building the platform that we all had wished we had when we were operating large machine learning deployments at major financial institutions. Keegan, if you could go to the next slide. Thank you. Just to give a quick overview of Arthur before I turn it over to Keegan, what does Arthur do? Well, broadly speaking, our focus is what are the tools you need to successfully manage AI in production and machine learning and data science in general. And so, there's a certain amount of operational maturity that if your models are going to be, affecting millions of dollars in business revenue, if they're going to be impacting consumers, that you need to have in order to really feel good about the way they're deployed, especially in a highly regulated environment. You need to be able to demonstrate that both to your internal compliance folks and to the regulators. And so the three major pillars that we solve for are being able to detect accuracy, both direct measures of accuracy when you have a nice ground truth feedback loop, as well as a number of indirect ones, because we know very often you don't have that ground truth feedback loop. And so all matters of drift and anomaly detection and things like that that we can provide out of the box. Being able to explain the decisions of your models, whether that's for the data scientist to help improve robustness, or if you want to present that in your application, so that the people who are having to action off of those decisions can have some context around them. And then finally, fairness. And so being able to not only monitor for and measure bias, but we also provide functionality that allows you to proactively mitigate it in an automated way. And so, it's a really comprehensive solution for everything after production. And, it's agnostic of how you deploy. So that's the nice thing. It's a very lightweight drop-in tool that you don't have to change the way you're currently running or deploying your models. So with that, I'm going to go ahead and hand over to Keegan Hines. And just a little introduction, Keegan. Keegan is our Vice President of Machine Learning. He's also an adjunct professor at Georgetown University, where he teaches in the Graduate School for Data Science. And previously, he was the Director of Machine Learning Research at Capital One, where he led Capital One's AI research efforts, both internal research efforts as well as partnerships with several major universities. He's previously worked in a variety of fields, including cyber defense and financial services, and all areas where machine learning is playing a really central role. Additionally, he's the co-founder of the Conference on Applied Learning for Information Security, CAMLIS, and holds a PhD in neuroscience from the University of Texas. So with that, I will hand it over to Keegan.
Great. Thanks a lot, Adam, and thanks everybody for joining us today. Really excited to chat through with you here about translating data science projects to maximize business value. As Adam mentioned, we spent a lot of time at Capital One deploying machine learning projects, and so as you'll see through the session today, some of what I'm going to lean on is drawn directly from lessons learned and mistakes made either by my teams or adjacent teams. And I think as we go through, you'll see some familiar things along the way. As we walk through, we're going to end up in a place where we can lay out a blueprint for how to think about your next data science project so that you can be maximally successful in making sure that you're really driving the business intent that you went after initially. So before we dive into that, taking kind of a bigger picture view, if we look at the landscape of enterprise machine learning today, you might join me in feeling this kind of juxtaposition, this kind of tension. So on the one hand, on the left side of the slide here, we have the promise of AI. We all sit around and every week some incredible new news story comes along about the amazing things that are being done at top research institutions, pushing the limits of AI. For example, maybe you followed the AlphaGo story over the last several years. This is a reinforcement learning system that can beat the world's best humans at the world's most challenging strategy games, and have really, completely changed that to the point where the best players in the world of the game Go have all but said, this is done. I can't compete with this algorithm anymore. Or, as the picture shown here in the slide, this is from a couple of years ago, a team and OpenAI trained a robotic hand to solve Rubik's Cube very quickly. And these advances are not just limited to games and game-like environments. If you followed the AlphaFold project, this is something that's in fundamental science. This is in molecular biophysics and involves the problem of what's called protein folding. This is a problem that has puzzled physicists and biologists since the 1950s, and the AlphaFold project has essentially solved this problem in the last few years. Using a variety of machine learning techniques, we can now go from a sequence of a protein, a DNA, an amino acid sequence, to figuring out exactly how it will fold. Again, this is a problem that has vexed, fundamental scientists for many, many decades. And in the last year, the leaders of this field are declaring this problem to have been solved now because of DeepMind's AlphaFold project. And just to hint at the implication of that, it's going to have huge changes for how we think about drug design and things like that. So, the advances that have been coming just in the last handful of years in AI research are truly amazing, across, previously kind of untouchable areas to really changing foundational science like biology and physics as well. Now, on the flip side of that, you might look around at your organization and not see that same amount of excitement, not see that same amount of movement, not see that same amount of progress or change. You might look back and think, well, we've hired a lot of really exceptional, talented people who have a great background in machine learning and a lot of great software engineers. But we haven't seen at our institution, our bank, we haven't really seen the kind of change that we're looking at here. It's been hard to get projects into production. It's been hard to handle the realities of regulation in our industry. It's been hard to think about compliance and governance in conjunction with some of these new machine learning techniques. And so there's a real tension here between these two sides that I imagine you probably appreciate a little bit from your organization. And so in our discussion today, I'd like to discuss a lot of reasons why that happens. Now, there's been a lot of talk about technological barriers to getting machine learning and data science projects into production. And that's very true. It's very hard to take a machine learning model and get it, into production easily and in a state where it can affect things. There's a lot of skill sets involved. It's not just something a typical data science knows about in terms of software engineering, DevOps, lots of different things. And so there are a lot of tool-based solutions that you can lean on for facilitating the process of getting models into production. Today, we're not really going to focus on that. I'd like to focus on other factors that often get in the way and are things that are more structural and organizational in your teams that might be getting in the way of making your data science projects as successful as they possibly could be. So technology is certainly a part of it, but today I'm going to talk about process and I'm going to talk about organizational structures that can help a data science project be as successful as possible. And so I'm going to go through I'm going to initiate this discussion through a few stories. And so these, as I mentioned, are lessons learned through previous companies that I've worked with on my teams and adjacent teams. As you can see, there are as you're going to see, there are a lot of hard lessons learned that I'm embarrassed and happy to share with you here. But as I go through, think about how these things might reflect or be a mirror of situations and organizational structures in your teams, and how going forward we can kind of reorient and rethink these things. So if you'll indulge me, I'll dive into a few stories of past data science projects. And so the first one of these stories I'm going to call the hopeful. And this is really a story of optimism, albeit naive optimism. And so in this use case, we've got a team of data scientists who are new to a large organization, and they are excited. They've showed up with brand new PhDs and bright smiles, and they're excited to apply their new technical knowledge to a new domain, in this case in financial services at a large bank. And so they get comfortable with what's going on, and they're looking into what data is available, what problems could be solved, and they find a really cool data set and what they think is a really cool problem that's going to be really exciting. They go through the various components of the data science lifecycle. They find the right data sets. They curate the data. They do feature engineering. They think about algorithms and so on. And they go through those kind of typical motions that you might have heard of about the data science process. In this case, the use case they decide to jump into is related to customer experience personalization. So, can we use machine learning to change the way that customers view or see digital experiences when they interact with the brand? And the data scientists involved in this project, we were really eager and convinced that we could really solve this problem, using the data that we had about customers to think about personalized experiences for them. And so after some weeks and months of work, coming up with algorithms, again, going back to feature engineering and so on, honing in on the machine learning task that really had to be solved there, we were extremely excited. We had gotten a model that was highly accurate, let's say 90% or above, done all the rigorous evaluation and testing to convince ourselves that the impact here was real. And we were super excited, had bar graphs and all kinds of visualizations showing how effective this model could be at predicting things about customers and customer life cycle. And so the team goes into the business leaders and presents their findings. They stand with their heads tall, very excited. Look at these great bar graphs. Look how awesome this is going to be. To which the business leaders and the folks on the business side kind of smile and nod and pat the data scientists on the head and say, "Good job, data scientists. Thanks for trying." The problem here was that the use case the data scientists had solved was a good use case from a mathematical perspective, but didn't actually matter very much from a business perspective. So the business line didn't think that it was really going to move the needle, that it was really a very impactful project in the grand scheme of things that was very well aligned with their business initiatives for that quarter or that year. And so while, yes, the machine learning project itself had high accuracy and was successful from that standpoint, it was not going to be something that was really going to be highly impactful for the business. And so there was a misalignment there, right? The data science team had all the mathematical knowledge, all the engineering knowledge. They lacked business context. They didn't really understand the business that they were operating in. And so for that reason, made the mistake of what to work on. From the business side, yes, even though this model was successful in some sense, it didn't really matter, right? The problem that was being solved wasn't so important that it even needed to be solved that quarter, and was probably not worth the time and attention of building a system and maintaining a system around this. And so you can see that the mistake here was one of structural isolation, that the data science and the machine learning teams were in one corner of the company, the business lines were in another corner of the company. There was an attempt to find energy there to work together, but something was lost in translation in terms of what the important things to work on were there. So simple lesson learned about making sure that your machine learning teams, not only are they, quantitatively minded and have all the right background and training, but make sure they're deployed against the most important problems that your business is working on in that quarter and in that year. Because this is often something that's very challenging for data scientists to learn about and understand kind of the business context in which they operate. So in the second story here, lesson learned, not going to make quite that same mistake. So in this case, the machine learning team, they knew exactly what to focus on. They went and found out how to contribute to one of the most, if not the most important bottom line business problem at this financial institution. They were going to work directly in consumer lending, and they were going to revolutionize the way it was done. And so the team found the data, found all the different things that were going to go into this model. They trained the model, they did the feature engineering. They even came up with some really novel and exciting new machine learning techniques, ones that had never been applied before in this industry. They had amazing results in terms of outcomes in this lending use case, and it was extremely exciting. The improved accuracy was undeniable, and the team even went the extra mile to tie that to the dollars and cents of what that was going to mean for the bank. Right? It wasn't about data science metrics like ROC curves and this kind of esoteric stuff, but it was, let's tie it exactly to, dollars and cents in our lending portfolio and show how much better things are going to be, when we're done with this project. So at the end of it, the machine learning team went over to the business leaders, had a big presentation, showed how great and successful this was, and said, "Hey, look, I know you guys have been doing this kind of consumer lending for a couple decades, and I'm sure it's working fine. But look, we've we've come up with this new way. We've kind of revolutionized how you're going to do everything. Look at these bar graphs. Look how amazing this is going to be. There's billions of dollars to be made here. You can thank us later. To which the business leaders replied, get out of my office. I mean, the mistake here is obvious. There was alignment in one sense, but the problem here was thinking about the personas involved and how to make this a win for everybody. So obviously this group of, eager, if not arrogant data scientists tackling this problem in a vacuum outside of the business leaders and then taking it to them and saying, hey, we're going to transform your entire industry. This is not a message that was well received. And so thinking carefully about how operating in a large organization and the initiatives that everyone is going to be involved with. And so if you're going to deploy machine learning against your most impactful areas of your business, make sure you bring everyone along. Make sure it's not an us versus them mentality. For better or for worse, you need to realize that there are dynamics in your organization. There could be territorialism. You got to think about scope and who's working on what. And you need to think about making sure there's a win for everybody along the way. And so this kind of going off on your own thing is not going to work. Again, this was a case of the technology worked, the machine learning model was great, it tackled an important problem. The issue was it was a people problem. It was executed in the wrong way. And so the third story here, happy to say, lessons learned along those previous two mistakes. And so, in this case, this was a use case in marketing optimization, digital marketing optimization. And things went really, really well. So the machine learning team focused very clearly on a very important business problem. They went and worked side by side with the business team and working very closely with everyone every day. So there was no us versus them mentality. We actually had everyone sitting side by side back when people did that. And so this was machine learning people, business analysts working together to make sure that the right problem was tackled in the right way at the right time, and that everyone stood to have a win here. The project that was embarked upon was something that was very important to the business line, something that had been on their mind for a year or 2 years, but had not been able to be achieved. The skill set on the technical side was perfect. A great combination of a very advanced machine learning researchers and engineers and software engineers that were eager to tackle this new problem. It was really exciting for the technical team. They got to investigate and deploy some exciting new reinforcement learning technologies to tackle this problem in marketing optimization. From an engineering standpoint, it was a big win. Got to build some real-time infrastructure for solving the cool machine learning problem. And again, from a business standpoint, it was a big win for the marketing agenda for that organization. And so there was sort of collaboration every step of the way, from the hands-on keyboard people and the business analysts up through the executives all along. There was a win here for everyone. So this was not a zero-sum game. When done correctly, there's a win here for everybody. So you get to deploy exciting new technology, you get to impact your business in an important way, and really drive the agenda for, in this case, the marketing organization at this financial institution. So things went very well. This model was deployed to great success. Everyone was very excited, and it really did have a big impact on that marketing agenda, and it did work very, very well at first. And so then some time goes on. A month goes by, 3 months go by, and some of the key business metrics that we were looking to affect with this machine learning system, they started to drop again. Right. So at the initial outset of the project, we saw a big increase in conversion rates and click-throughs and things like that. Over time, we saw that fade a little bit, and sometimes it faded very fast. And it was not clear what exactly was going wrong. And so we had some poor intern spent weeks and weeks digging through some system logs to try to figure out what was going wrong in this machine learning system. And what things had we not anticipated? Turns out what happened was a problem with a data broker that we were using. And so it's not uncommon to purchase third-party data for a machine learning project. That happens all the time. this data provider changed the way they were computing some particular variable. Let's say they changed a null into a -1, something they thought was kind of a silent and inconsequential thing. Well, for a machine learning model, when a machine learning model starts to fail, it'll fail silently. So unlike a web application or a mobile app, when those fail, you know about it right away. A lot of times when a machine learning model starts to fail, there are lots of ways that it can fail very silently and very subtly. In this case, this particular data variable changed the way it was encoded and represented, and the machine learning model doesn't scream, hey, 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 here's a problem, but it just keeps going along making predictions. But unfortunately, those predictions are now changed, and they're probably changed in a very gradual way. And so the day that this happens, you probably don't notice it, but after weeks and weeks and months, this model is less accurate in its predictions. It's starting to make a lot of mistakes, and after many weeks and months, those mistakes have accumulated into real dollars and cents that you're missing for this machine learning model. And so, we found out that, okay, it was a problem in the data integrity. The data wasn't, stable or correct in the way that we expected it to be, and that was having a downstream impact on the model becoming inaccurate. And so the mistake in this story, right? And again, I'm happy to say a lot of success in this story in terms of the technology was successful, the business intent was successful, organizationally successful. There was a problem here around establishing best practices and governance around that model in the correct way. This was a pretty advanced model. It was a real-time system. I mentioned reinforcement learning. And so it was a bit beyond what the bank had thought about before in terms of governance practices. And what was missing here was some monitoring around the model. What we really needed to be doing was monitoring the input data to the model and the output data to the model, lots of different things about this large system to make sure that this wasn't happening, that bad things weren't happening in this way. And so, again, this story is successful up to, getting the model in production, and then a little bit subpar after the model was in production in terms of a lack of monitoring and best practices. So taking these three stories together, you might have noticed a few common themes emerge when we think about what was going right and what was going wrong. So in that first story, I told you the technical plausibility of the project was there. It worked. You could use a machine learning model to solve a particular problem, and that wasn't an issue. And actually, I would offer that that's probably always going to be fine. If you've hired machine learning experts and data scientists, they're probably going to figure out a way to solve a data science problem with some data set, right? It'll range in terms of how accurate it is and whatnot, but there's usually a way to get started. So I think that that's probably not getting in the way of many of your projects. But again, on that first story, what was missing was the business context and the business understanding. These data scientists didn't have a good notion of what was important for this organization and what they should be working on and what would be really, a high leverage use of their time and their skills. They didn't have organizational alignment, certainly, because they, didn't quite have that buy-in with what they were doing. And they certainly didn't have operational maturity in their practices there because they never quite got there. In the second story that I talked about, we had a lot of those things. Technical plausibility was great. It was a great technical project. The business understanding was there. The thing that was being worked on there was a very important use case in auto lending. But of course, the problem was organizational alignment. There was territorialism. There were missteps that were made in getting that model into production. And we need to be very mindful of the organizational structures that we create and how to make sure that there are shared wins for everybody. And then in that final story, again, good news on the first three fronts, a great technical project, great business understanding, again, aided by the fact that our machine learning teams and our business teams are working very close hand in hand, again, emphasizing that organizational alignment between these two groups. And then the missing piece there on operational maturity, once the model is done. And so here you can see, important components to think about that range from technical to organizational as you go into the next data science project that you're going to embark upon, or ones that are currently in flight. So that sets up a blueprint that we can think about following for our data science projects as we go from kind of ideation into production and post-production. And we can break it down into these 4 steps that I'll walk through here. But it starts with thinking about a business case, build a business case. This is something that your data scientists might not be that adept at, right? They're going to think about data science metrics and optimization problems and gradient descent and all this technical stuff. They're probably not going to be that adept at thinking about the business case. So they might need some help there to ensure that, hey, if we go through all this stuff, will there even be ROI, right? Is there a business intent here that even matters? Then thinking about, involving cross-functional stakeholders, again, making sure there's organizational alignment and shared wins across the board. Thinking about the success metrics, right? Tying back to that first point up front to make sure that there is ROI on this investment in machine learning and how you're going to measure that. And then in the 4th step, measuring along the way. So diving into here, a little bit more into each of these steps. Build the business case first. And, I think that this is often overlooked by machine learning teams. Again, it's a bit outside of their wheelhouse. They're probably not accustomed to thinking about doing this kind of cost analysis, ROI analysis. So I wouldn't expect them to be able to do this off the bat, but if possible, if you can partner, a business analyst kind of persona in there, it can be really impactful because it can shape, what directions a project might go that are really going to be worth the ROI. So for example, if we improve our machine learning model by 1% in a credit lending application, and we think about kind of what that does to the portfolio and the losses and the exposure on the portfolio, right? You can walk through the dollars and cents of what that could mean. And at the end of that, you could decide, okay, a 1% investment wouldn't actually be worth the effort, a 1% improvement, but maybe a 3% one or a 5% one would be worth the effort. And you could take that back to the machine learning team, and then they could say, whoa, 5% improvement. I don't know if we're going to get there, with what we have. We need to rethink things. And so it's a lens that a lot of technical teams aren't taking, but it can be, really helpful in ensuring that the way you work on is as impactful as possible. Step 2, again, getting involvement with cross-functional stakeholders from the beginning. This is not going to be we build a model and hand it over to you and, hopefully it works and see you later. Make sure everyone's involved from the get-go. Think about, who's involved in the problem right now. What is the cost of the problem without machine learning, and make sure they're in there with you, or let me phrase it differently. Make sure the business line is committed in terms of resources, right? If they're not willing to put some business analysts involved in this project, that's not a great sign about the success of the project. So if we're going to put engineers and data scientists into something, we need to see, both sides really committed, and creating mechanisms for engaging leadership and stakeholders, all across throughout the life cycle of a project. And again, thinking about the success metrics up front, your data scientist is going to think about false positive rates and these kinds of things, but really defining the business KPIs you're trying to push. So maybe it's fraud losses, maybe it's marketing conversions and things like that, and making sure that you have the data available to measure that in the same cadence that the machine learning model is doing its work. If you can't get access to your marketing conversion rates until 3 months, in a 3-month cadence, then doing a real-time marketing use case, it's going to be really hard to understand if it's working or not, as an example. And then measurement along the way. And, again, this comes down not just to kind of the technical and monitoring things, that I mentioned about the data and the model, but also the metrics that we talked about. Again, making sure that you're checking in on, your core business KPI that you sought to change there, fraud losses, things like that, and understanding how that's going. Once a model's into production, you're probably going to see it go through, many phases of iteration and improvement. Version 2 of the model, version 3 of the model, version 10 of the model. Thinking about how measurement fits in with that, understanding the impact on your business KPI as a result of improvements on the model. Being able to tie that conversation together between business analysts and the modeling team is really important. And so, a result of this kind of approach is that, we can deliver, efficient and sustainable value to the business. Repeatable success with AI is going to be, composed of the following things, right? All stakeholders are going to have shared wins here in what's getting done. If you think about how we can use the processes and the technology that I alluded to before, we can streamline a lot of the stuff that's frankly rather slow in financial services. So especially when we think about governance, we think about model risk management, we think about fair lending. Now these are very, very important second line risk functions, but you often hear data scientists and technologists complaining that they slow down innovation. And that push and pull is important and it's necessary. But if there are areas of your model risk and governance process that are a bit laborious and can be automated, look for ways to streamline. If there are areas of your fair lending process that are laborious or are reactive, you can look for ways to streamline and automate so that when you think about, is our model impacting people in a way that's causing disparate impact across race, age, sex, or anything you want to look at, having a quick glance at that so that it's not a 3-week process that stops a model from going into production. It's something that you could start to build into the model development process from day one and then continue it into as the model's in production. And so throughout the course of that, you're proving out the value of a significant investment in machine learning that you've put into your organization. And I would say that expect to build in time for learning. I've found that as you bring machine learning projects into different business areas, there's a lot of excitement. Everyone loves to learn about machine learning. Everyone without that background loves to learn about it. It results in great creativity and great engagement across your business, and people are often going to want to dive into taking online courses. Learn maybe they're not going to get to the point where they're coding, but it's great for your organization overall if you're undergoing a transformation into a broad adoption of machine learning, that everyone's going to be learning about this stuff and getting very excited. So at Arthur we work with many of the world's largest financial institutions as they deploy machine learning in their environments, and of course these are complex heterogeneous environments with many hundreds of data scientists and hundreds of models in production, and we've kind of seen a lot of these patterns over and over again in lots of different use cases. And so, thinking about these best practices and monitoring for things like fraud use cases, and instead of troubleshooting for weeks and weeks, like I mentioned in my earlier story, and kind of exposure to lots and lots of risk, having automation around, this model looks wrong today, let's just get in there and fix it. It's going to save you a lot of effort and a lot of money. As I mentioned, fair lending is something that's very crucially important in financial services and in consumer lending, and obviously is becoming even more so. We saw the note from the CFPB last week touching on guidance around these complex and non-transparent machine learning models and what we should do there. And so across model explainability and fair lending, these are tough issues that are really important to wrestle with. And yeah, so we've seen success across a lot of different financial services use cases, and call center activity, in anomaly detection, in internal insider threat and employee fraud detection, lots of different things. So excited to chat with you and your teams if you're going down your ML journey in your organization and thinking about a lot of these tricky issues, kind of bridging across complex machine learning and explainability and monitoring. We'd be really excited to engage with you there. So thank you so much for joining us today. I encourage you to stop by the website here, and you can download a PDF that kind of walks through the step-by-step that I talked through there, in terms of best practices for your next ML project. So we've got a 2-pager there that you can take a look at after the fact. But thank you so much for joining us today. We're going to switch it over to Q&A now, so feel free to jump into the chat if you have any questions. But thanks again for your time and your attention this morning. So let me switch over to, hey, Victoria. Great, so Victoria from our sales organization is going to jump in and help facilitate some questions here. Thanks a lot, Victoria.
Of course, yes, I'm starting to see some come in. Keegan, I think this one relates to what you were talking about a bit earlier in terms of streamlining things like governance and compliance. The question is, what trends are you seeing in model risk management? And also, can you speak to the relationship between model risk management and data scientists?
Yeah, absolutely. So, what you typically see in MRM is a separation of duties, so that they're a second line risk function that doesn't work on building models, but they work on a compliance and a challenger function. So there's intentionally an adversarial relationship between model risk and model developers, and that's to make sure that only the best stuff gets out there. And that's a practice that we've seen for many years, and it's a practice that I would also say that everyone agrees is very laborious and very slow. Most notably the long white papers that you write for models that go into production, right? 100 pages or more, very laborious. And then after that, the task of model monitoring tends to be laborious. We've heard from some of our customers in financial institutions that the task of monitoring models, again, that somebody else built 10 years ago, can sometimes take a data scientist 1 month of every quarter, right? So that's a third of their time is spent on babysitting and monitoring a model from long ago. And so the trends that we're excited to see is automation around a lot of that. A lot of this stuff doesn't have to be reactive. It doesn't, it can be something that's always ongoing. When you think about model monitoring and risk management, when you think about the setup to, initial model risk assessment, a lot of this stuff can be automated and streamlined so that your data scientists can focus on the interesting stuff. They can focus on thinking about fraud. They don't have to focus on thinking about babysitting somebody else's model.
Great. Another question is, how do you think about performance of fair lending models specifically?
Performance of fair lending. Maybe this question is getting at, so when we think about model fairness and bias, there's often a trade-off that we think about there. And in the research community, it's often referred to as the fairness accuracy trade-off. So if you have a model that is trained upon a large population of customers and users, it's probably going to be the case that you accidentally have introduced some sort of disparate impact or bias in that model, right? There are going to be subpopulations and subgroups of your space where the model is less accurate. This ends up being just kind of a statistical necessity. You train a model through an optimization process. The model is going to do its best on the majority, and it's probably going to end up being inaccurate on a minority group, whatever that minority happens to correspond to. And so in the research literature, there's often this thought about a trade-off between model accuracy and model fairness. So if we want to make a model more fair, if we want to reduce that disparity, we might have to give a little bit up in terms of accuracy. So the model that is absolutely the most accurate is probably going to be biased, and the model that is absolutely unbiased is probably going to give up a few points on accuracy. And this is something that's generally true. There have been a few papers in the last couple of years looking at cases where it's not always true, right? You could find that a fair model is just as accurate. And so there's a little bit of a trade-off there. But there are many, many algorithms for thinking about training fair machine learning models, or doing what's called bias mitigation in machine learning models, where you can get to fairness of a model. You can get to a fairness constraint with absolutely minimizing the impact on accuracy. So you want to take the smallest hit possible to accuracy while also being fair. So we found that in a lot of organizations, instead of your model being 97% accurate, maybe it's 96% accurate, but it feels much better from a fair lending perspective because you've assessed and you're taking a look at, okay, we're not having disparate impact across sex, across race, across age, and we'll take that 1% hit on accuracy, and that's worthwhile for us.
Makes sense. I see one more question. We encourage folks to please feel free to drop them in the Q&A. Regarding the AI native financial services organizations out there, you talked about some of the elements in this in an earlier slide. What do you see as the largest drivers of success in those organizations?
Sorry, could you say that last part, largest drivers of
Success. So
Yeah.
where organizations might be more AI driven natively and kind of a little further along in sophistication is what I think they're getting at. What do you think drives that success the most?
Yeah, great question. And, as I've reflected on this, I really think structurally is a big issue. I think there's been a lot of talk about technology challenges that get in the way, and they certainly are, and I've alluded to some of them. But, if I just think back at organizations we work with at Arthur and organizations I've been a part of, the mistake is you want to make sure your data science teams, your machine learning teams are really embedded and they're working closely, right? And so, as you think about hiring, you can think about different structural models there. You could have kind of a center of excellence model, or you could have kind of a matrix model and things like that. And, I think for any specialized skill set, and in this case, we're talking about machine learning, I think it's best to get people, close to the problems, as close as possible to the problems and in the business lines. So then the flip side of that is you want to build communities. So if you have, each machine learning person or team is kind of sprinkled around the organization, they might find that, yeah, they understand the business problem they're working on, and that's going to lead to quicker success. But you'll probably want to do some community building, right? Having weekly or monthly chats and workshops for all your ML people to get together and exchange ideas, because they're going to be in far-flung corners of the company. So, there's a little bit of culture building that you'll need to do there to keep them excited and engaged and collaborative, because, maybe they're spending most of their time not with other ML people. And so there's going to be, part of the learning and culture that you'll want to keep up with there.
This ties in nicely with the new one that just came in from the audience as well. So among the stories you shared and the missing pieces in the puzzle, which one is the hardest to crack based on your experience?
Yeah, I think it's the structural and organizational one. And there's a recruiting challenge. If you go the other path of kind of a center of excellence, you can recruit there more easily, I should say. So if you say, we have a new AI research center, people are going to be excited to join that. Probably more so than if you said, we have a machine learning job on the marketing team. It's a little bit of a harder sell from a recruiting perspective. And so that's the back and forth that you need to think about. And so, we've seen success in a past organization of using the center of excellence as a strong recruiting mechanism, and then getting that work out into the business areas and kind of deploying teams outward from there. And you can try to balance the best of both worlds in that way.
Makes sense. There's a related one, I think, when you talk about the organization. There's a trend of sort of centralizing these efforts and decentralizing them. I'd be curious, it sounds like, for your perspective on this and what's worked or the challenges of one versus the other.
Yeah, exactly. Yeah, this is right in there too. You see, to be honest, a pendulum swing within one organization, back and forth even over time on that question. And so, the benefits of centralization again are, recruiting is good. Excellence in skill set is easier there. You can kind of have this group together and make sure that they are the best in terms of knowing what their specialty and things like that. The downside of this is they're going to be a little bit siloed. It's going to be harder to deploy them here and there, and you might run into some of those frankly organizational politics, right? If you're trying to deploy them in this corner of the company and that corner of the company, there's structural problems in the way. People are going to look a little skeptically at that. And then, the other side, the matrixed way or the more decentralized gets over some of that stuff. But again, it's a little more challenging to bring people in and hire. If you imagine you have two machine learning people, you deploy them in a marketing organization. The challenge there is keeping them excited and engaged, because probably the managers that they're spending their time with every day, the leaders they're spending their time with every day, they don't know that much about machine learning. It's going to be hard to help them grow their career, right? And so you need to think about, if you're in the distributed and matrixed organization, again, kind of creating communities for growth, and creating ways to kind of ensure that everyone's career trajectories are considered and aligned.
Certainly something I've witnessed too with organizations we work with. Very timely question around regulation. What do you see as the best way to stay ahead of some of this across these teams?
Yeah, great question. We talk to regulators frequently. We were speaking recently to the authors of SR 11.7, and I think the challenge here is that the world is kind of in a stalemate right now, in kind of a paradox between machine learning practitioners. They want to use these kind of exciting, intriguing new machine learning techniques, but they are afraid of this abstract concept of regulation. Oh, I can never use this because a regulator is going to tell me I need an explainable model, for example. And then on the other side, of the regulatory side, they're never going to provide specific guidance on what it means, to have an explainable model. As an example, kind of in the weeds here, right? There's an explainability algorithm called Shapley values that's very popular. I would never expect a regulatory body to say something as specific as, if you're using SHAP, it's okay, right? That's not really their role. They're not going to get that specific. And so, you have kind of this stalemate now, where it's not exactly clear where to go forward and where not. From the regulator standpoint, they don't want to get in the way of innovation. In fact, when they've told us that they want to encourage innovation, they want to encourage new machine learning techniques, because they see this as a way to provide credit in places where credit's inaccessible, right? Thin credit files and people that are new to the country and things like that, where it's very hard to get credit. They're optimistic that machine learning algorithms can help open the open access to credit. So they often don't want to be a deterrent, but at the same time, it's kind of tricky. And so I think that there's kind of an unfolding conversation going on over the last few years, and certainly during the next few, about what kind of the right techniques are going to be and the right ways to think about it. We saw this note from the CFPB last week, and my reading of that was, they were saying that it is not an excuse. Using a complex machine learning model is not an excuse to not provide a turn down reason, for example, in lending. Right, that you can't just say, oh, this machine learning model did it, and so I don't know everything that went into it, and so I can't do it, right? So their note is, it's not an excuse, but they were not forbidding the use of complex machine learning models. They're just saying, like, you're still on the hook to do it. And so then step two is, well, let's turn to explainability techniques that can help. Or maybe step one is, let's use inherently interpretable models, right? And that's kind of a different decision path that your data science teams can think about. But in that case, we saw that the guidance was a gentle warning saying, like, you're still on the hook for this. We're not going to tell you how to do it, but just be aware that you're still on the hook.
That ties in very nicely with yet another one that came in from the audience, related to some of these methods and techniques that are available. So what have you found that's been useful for getting the buy-in on these machine learning models that industry professionals might not be familiar with? They've said, we've built great models that go unused because business leaders aren't comfortable with the methods. So in your experience, how can you go about getting that buy-in?
Yeah, that's a great question. So, there are two families of techniques, I guess, that are, or approaches that are worth talking about. And one would be families of inherently interpretable models. Now, that would start with kind of the classical statistical methodologies that probably underlie what you've been doing for a couple decades. But in recent years have extended to types of machine learning algorithms that are more sophisticated, but are designed with some very specific choices and very specific constraints that lend themselves a little bit to some more inherently interpretable outputs. So it's not quite as like logistic regression, but you can get kind of close. I think that is a good way to go for a lot of use cases if you find that tension is really tough. And then the other side of the coin is going down the path of using whatever machine learning technique you want to solve the problem, and then bringing in what are called post hoc explainability techniques. And so these are things that are going to be able to say, if Keegan gets turned down for a credit card, what were the top 5 factors in the model that made the model do that? And so there are many techniques there. There are some that are kind of rising to the top in terms of popularity in the scientific community that you might have heard of, algorithms like the Lime algorithm and the Shapley value algorithm. And these are components that you can apply on top of any machine learning system, after it's done, that help to explain it. A third one that I'll mention that we're particularly fascinated by is a different approach to model explainability, and it's called counterfactual explanations. So here the idea isn't explain why Keegan was declined this time, but it's instead, Keegan was declined. What would he have to change about himself to get approved next time? And so a counterfactual explanation says, okay, this time you were declined, but if you increase your income this much, and if you increase your FICO score this much, then if you applied again, we're pretty confident that you would do okay, that you would get in. In a technical sense, in technical terminology, it's about getting to the other side of the decision boundary of the model. And so that's a highly interpretable notion of explaining what a model does, and could be a really exciting mechanism for a user experience, as an example, and a different way of thinking about a turn down reason, as an example.
Perfect. Thank you, Keegan. I think that takes us to the end of questions.
Awesome. Well, thank you so much, everybody. Really appreciate you joining us this morning. Thank you for the great questions and the great engagement along the way. And again, see if I can put that link up one more time while we're, nope, I lost it. I think it's arthur.ai/bestml if you want to download that PDF. So thanks so much, and I hope everybody has a great rest of the week.